Bloop. So this is where we left off last time, and we already wrote down our curvature. Now that's not the answer. Going back here, they got this thing, and we were talking about. Well, that's not anything close, but it is kind of. So what are they asking for is not the curvature, it's the equation of the circle, right? And let's just talk about circles for a second. X squared over, no, that's still too much, way too much. It's a circle, right? X squared plus y squared equals r squared. That's the circle. But because we're going to be not centered at 0, I'm going to do a tiny bit more complicated formula with a center at x naught, y naught. So that's off center, I guess. So that's the true formula that I want. They're emphasizing the fact that we're wanting equation of a circle. So there we go, we have it. Now I just need to fill in my 3 results. Where's it centered? What's the radius? Cool. But we have something to help us. This guy right here is the curvature, and we know that curvature is 1 over r. Or rather, we can say r is 1 over curvature, right? So either way, what we're going to do is basically blah, blah, blah math, and we get our radius, pop it in, and we're super, super close, okay? But how do we get that? Sure, but it's not entirely ready because we still have x's in there. And that's, what do we do there? There it is. There it is, right here. That's an xy point, isn't it? So we plug in this 4 pi, and then, like you said, we flip it. And so I'm going to plug in 4 pi, and rather, I want to be able to do this without too much overhead, if that makes sense. Let me try a different color. So this guy right here is going to be a 4 pi. This guy right here is going to be a 4 pi. What would this inside end up looking like? Like here. Yeah, 2. So we got the, right. So yeah. Hold on. So yeah, we got 5. Yeah, it's the other way. 5's halves. 5 halves. I do the same thing. Thank you. And like, where on the unit circle is 5 halves pi? Yes, it goes all the way around, back up over here. It's basically straight up. And so, in a way, when I say sine of this, I'm saying sine of 90. This whole thing here is going to turn into a 1. And then the cosine is going to turn into a, wow. So that's kind of nice. It makes it a lot easier. So I'm going to do 1 over, just because I'm being silly now for a second, 25 over 64 divided by 1 plus 0, because everything turns to 0 right there, to the 3 halves. And you can see that I'm going very ridiculous here, because you don't need all that. Essentially, you're going to take this bottom one and flip it. 64 over 25. That's my expected radius. And I want to verify. And I'm like working backwards a tiny bit. I know it's kind of tiny. I'm sorry. Can I plus sign? Wonder if I could do something like that. Is that a bit better right there? Eh. Okay, good. Yeah, that's a 0, yeah. There we go. When I flash the answer, I'm going to ask, did I have the answer? There it is. I haven't yet squared it. That was r squared. So 64 times 64. Nah, I don't know that one. But I do know 25 times 25. 625. There. And the other one is a power of 2, so it's probably right. So we're definitely on the right track. This is good. I like this. Smiley face. So now we need to figure out where it's centered. And this is actually the bigger leap. And before class, I was thinking, should I do this their way or should I do it my way? And I'm going to try my way, and I might get it wrong. But I think it'll be fine. Are y'all okay with the radius? Plug it in, flip. Easy enough. Now, to find the center, I want to go back to what we're kind of looking at. And this right here is a really great picture. So we have this circle, and we just found the radius, this radius right here, from here to here, r. But I need this center here, this, I guess you could say x naught, y naught kind of thing, okay? So how do we get from the point that they gave us, which if you remember was the 4 pi comma 1, right? That's what they gave us. How can I find this from that? Like, what's the direction? It's pointed right at you. What's the direction? Yeah, n, normal vector. Ooh, didn't want to do that. Didn't want to do that, right? Because I have to go and find t, and then I got to go find n, and it's a really long process. Not fun at all. So here's my thoughts, though. And even they have an n right here and n right here. But if you go back to the formulas for n, essentially we're saying take the derivative of a derivative, right? Here's the first derivative, and we're saying take the derivative of that. So I'm going to say like it's roughly the second derivative. Roughly? I know. Chad, that's pretty rough. And it is pretty rough. I'm only wanting direction. I only want the direction. So I think that I can maybe slide by just saying second derivative and hope for the best. Probably not going to work, but we can try. So when I go back to the problem, I want to basically find the second derivative, not this guy, this one. Because like this is vector stuff now, right? In a way. So let's try that. Let's just see what happens. Maybe we get something happy and pretty. So my regular r is the 8t sine 5t, okay? So my first derivative. Good. Sorry. It's kind of like a, okay, now what? And then? Yes. Yes. Very good, very good. This is going to be my direction. I'm going to say direction. Direction. Will that work, though? So let's think about it. Let's do a little bit of math and stuff. This didn't give me a t value, right? But what would be the t? Like if x is equal to 4 pi and x is also equal to 8t, I'm saying 8t is equal to 4 pi, then what would my t equal?
Wouldn't that be 1/2 pi?
Yeah, exactly, pi over 2. And what if I put a pi over 2 in there? Sine of 5 pi over 2 makes we just saw it, a 1. We just saw that. So in a way, I'm saying that my direction is this guy. Or straight down. Straight down. As in, like, if I'm going to do a unit circle, it's going this way, okay? This is very good in so many ways. You want to go flash the answer again? Watch this. Look for the pattern. Do you see something telling you, indicating to you, straight down? Straight down? Leaving it up for you to kind of think about it. There you go. There's one indicator. Okay, it's because we went from a positive to a negative. I like that. I didn't think about that one. That was a good one. Is there another one? How about not just down, but straight down? Another indicator? How about right here? These are the same. My x values are the same. How much x distance did I travel? 0. Is my direction confirming itself? Going down and no change in 0. Okay, so I think that'll work. And again, I don't care about the 25. Like, ultimately, this is not a good way to see it. It's more like this, because this direction, you know? I just wanted to say, we're going straight down. So how much straight down am I going? How much distance do I have to go down? Take a guess. Let me scroll down in there and take a guess. The radius, right? Because if you think about it, what we have is a point right here, and they say that's 4 pi comma 1. And then I'm going to go straight down, and I want to find the center at, well, 4 pi comma blah. And to get that, I go down a radius. So I'm literally subtracting this guy. And so my y value would be the positive 1 that I started with, subtract 64 over 25. That's calculator. If you don't mind, I'm going to use a calculator on that one. Calculator, bump, bump, ba-dum, bump. Here we go. Yeah. And then if you go back and flash it, look at that. It worked. Again, though, this is negative, and the reason why is because our formula has a minus sign. 2 negatives make a positive, and that's how they get the final answer. So this was a little bit of, you know what I mean? It wasn't so formulaic, I guess you can say. Nevertheless, I think that it was fun. Again, I'm going to remember to square it, okay? So that's my final answer right there. There we go. Final answer. I have my formula. Need to find out what to do. Let's talk. Or, well, I'm here for questions. So if you want to talk, I'm here to talk. Go back over anything you want. I know, right? Magic. Sometimes at least. Uh-huh. The answer is yes. I got lucky, didn't I? I got lucky because going straight down, that's a nice thing. But let's just say I didn't. It's just on the side for a second. What if my direction was like 3 comma 4, something like that? So then I'm like going this way. Well, I would, for direction, I would have to do the unit vector. And so I could divide it by its magnitude, and then I would get its unit direction, toss in a multiply, and call it a day. So, yes.
So it's simple. It was simpler, but it's still doable.
Very still doable, yeah. And if you really, really, really want to do the formula with n, by all means, that's no problem, right? You can find, like, you don't need that whole crazy, you don't need this. You just find n like we normally do after 15 minutes and maybe 30, depending on the class, right? 30 minutes, find your n, and you're like, okay, cool, now multiply, and you would get the same thing. So I'm kind of like doing a shortcut. I'm saying that n is kind of like saying r double prime. Kinda. Well, it's precise in the direction.
Right.
It's just not giving you how far. But I don't think that was the purpose anyways, because we needed how far was the r, which we already had.
Right.
So, yeah. Let's do some more. I know, right? Or I can have you. Oh, look, perfect. This is a you do for sure. Yes, this is a good one. Forget about the maximum for. Well, okay, forget about that until the second part. Find the curvature, and you have that formula. I'm gonna rewrite the formula for you, anyways, and y'all start doing that. We'll take care of the maximum part in a minute, unless you're ambitious and want to do it now. can come and help out. I have to remember to remind myself that sometimes. I'm thinking early next week we could probably do the lab. Maybe Tuesday. Is Tuesday a good day? Yeah. Monday? Oh no, I'm sorry. We'll record it, and if you got questions, I'm here. Cool. I gotta say, this is a classic problem. This was also in the WebAssign. Zooming out, it's a pretty cool problem. I think the very first part's a tiny bit tedious, but that's why you're doing it. You pay me for me to stand here and watch you. Doesn't make any sense, Chad. That's a thinking face right there.
Yes. Well, I'm trying to figure out because aren't giving it points. We can't quite solve it like how we did the last one.
Did you get your curvature?
Yes, I got solved for the kappa.
Yeah. Now you're trying to go on to the hard part.
Oh yeah, we're trying to find R and all that stuff like we did the last one.
More second. We'll get to the fun part here in a few minutes. Is that also a thinking face? Okay. I would ask, like, what's the answer? But it's like, blah, 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 right? So it's so much. It's not something easy. Am I right? It's big. Oh, not too bad. Okay. You said, I don't know, relatively. What is my first derivative? Let's just do some basics, right? So y prime. 8 over x, 5x. But they cancel, exactly. So yeah, 8 over x, straight up. And then my y double prime, when you take the derivative, I think it might just be an 8 still. Let me verify. So we actually have this, and I'm going to take the derivative. Yeah, I know. Integrals, though, it would have been 16, right? Because I know. Okay, so it is an 8 in the top still, which actually will help us to cancel things here in just a few minutes, which is kind of nice. Yeah, I forgot about the 5 canceling, though. That was a good thing. See, we're helping each other out. So the absolute value is going to knock out that minus sign here in a second. But what about this x squared? I mean, I say, oh, well, it was negative. Now I make it positive. But like, what if this was negative? It's never negative because it's squared. 2 negatives make a positive. So like the absolute value will actually just be this, always. Very good. My first derivative, pop it in down here. Whenever I'm squaring it, I get the, oh, I don't get the same thing. I get this. And then 3/2. Well, I think we're going to have to spend a little bit of time doing some simplify. Maybe. So I have a question. This is more of a, what do you think? Okay, because I had to like write tiny and stuff. Are y'all okay with this? Is that what y'all got? Did you keep simplifying? No? Yeah. I don't know either. So here I'm gonna let's do a vote. So it's, do I keep simplifying or do I not? The idea though is that we have to find the maximum curvature. We found the curvature, now we need to find the maximum. Cal 1, how do you find maximum? First derivative equals 0. Exactly. We're basically saying k kappa prime is equal to 0. Solve for x, I guess? I mean, and there is an x right there. So that seems like it's down the right road. First derivative equals 0. That's interesting, isn't it? So I'm going to be taking a derivative of this. Should I simplify now, or should I just push harder? Simplify a little bit. Yeah. And so now you didn't have me for Cal 1 and Cal 2 because they don't let me teach those classes. Your professor made you simplify. For what reason? Gosh, I'm going to get to Chad's class and not simplify anything. Now you will. Oh, there might be an easy way to do that. I'm a simpleton. But yes, there are definitely easier ways, I'm sure, to kind of just, like, for one, I see that we're doing like the square root of the squares, and I think they're going to cancel a lot. I can't give you a perfect answer yet. That's a good idea, though. That's a very good idea. Okay. So, to simplify this, I want to get a common denominator down here. And it's not great. In fact, you know what I'm going to do is I'm going to get a little bit more room on this side. So, yeah, here we go. Okay, so I had the 8 over x squared, and then I'm going to have a common denominator of x squared over here. Okay. And that little half is technically a square root. I don't want to square root the whole thing right now, but I can pop this guy outside of the square root. Now, I have to be very careful because he's also being cubed, right? So there's like a couple moving parts there. So what I'm going to do first is I'm going to just say leave the top alone. Don't change the top. Okay, so this is like big division, and this is like little division. So I want to pop them out. So when I pop out an x squared out of a square root, I get x, just x. But then you're cubing it. So there's actually a cube down here. It's a little weird to do like the 2-step jump there, but yeah, the square and square root cancel, and then there's a cube that still applies. And so I get x cubed divided by x squared, and then all this junk. And apparently junk is not the word to use with the boss with math. I learned that yesterday. So maybe stuff would be better. She was showing me a problem like, anyways, x cubed, x squared. Yep. Okay, now let's major pause. Major pause. I'm going to cloud this guy. I like cloud. Cloud says we reached a milestone. It's not quite boxed in. It's not a circle. So really awesome. I think we've done a lot of great stuff. Why is that easier to take a derivative of that guy? True. So yeah, it's a little bit easier to look at, but there's a key vital element that makes it like like a connoisseur of math. Why is that one better for derivatives? No? Could I do quotient rule? I know that quotient rule is not my first go-to, but and the bottom of quotient rule is going to be squared, and that's a square root, kind of, right? So those would cancel. If I were integrating, that'd be easy too, by the way, right? Use substitution would be pretty simple. So like this is just nice all over for a lot of reasons. I think I'm going to do quotient rule because I think the bottom's going to cancel and it's going to be really pretty in the end, I think. So remember that this was my curvature, and now I'm stepping to the derivative. So in proper math, you could say like a new line or maybe arrow, but you can't say equals. They're no longer equal now, okay? So here we go. Now, low d high minus high d low divided by the square of what's below. So just as a little reminder there. So low d high minus high d low 1/2, yeah. And then derivative of the inside, very good. All divided by the square of what's below is now just a cube. Just cube it. You got rid of the square root. All right, not pretty, but but I mean, it was all at once, and we're done with our derivative, kinda. Now, one goal to see ahead of time is that we're trying to make this equal to 0, right? And what makes things equal to 0 when you're talking about fractions is the numerator, the top. And I know that's the ugliest part, but I can at least kind of erase the bottom. I don't really need the bottom. The bottom's not going to help me. So I need to like focus on how to get this guy equal to 0. What do the two halves have in common between these two halves? Yeah, that square root square thing. Yeah, exactly. I think I can at least pull some of that out. And notice that they're both half power. They both have half power. So I'd rather get rid of the half power because that's going to be the weird part anyways. Leave behind 8 times something. And then over here, everything's kind of just going to fall into place. So I want to get my numbers together. The 2's cancel. I could say that. So that's kind of nice. 24x squared, very good, because I got x and another x. Thank you for that. And then divided by stuff, which we don't really care about. But what goes here? If I factor out a half, what's left? I took the square root out, but is it the cube? Or is it a square? Or is it a 1? I know, it's kind of weird. Let's do some like proto math on the side, because I can't remember. So I have x to the 3/2 minus x to the half. And I want to factor out x to the 1/2. And I know that's going to be a 1. So then this guy here is technically 1.5, right? 1.5, and this is 0.5, and I'm saying 0.5 is what came out. So then if I took 0.5 away, am I left with a 1? And let's verify. whenever I multiply my bases, I add their powers. So is 0.5 plus 1, 1.5? So verified. And the same with this guy, of course. So it's like I'm taking out the point and leaving the 1 behind. Okay? So this is, and this stuff right here, I'm not kidding you guys. 5, maybe 4. But we don't think about it much, do we? How often do we do this? So it's one of those little rules that even I think, whoa, 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 let's slow down, right? Everybody has this. And it's fun to like say, that was cool to go back to olden days. 1 power. 1 power. I'm going to use a different color now. This orange is eating at my eyes. Distribute. I don't really care about this guy. I don't care about this guy. Let's just focus on this stuff here. So I shouldn't say equals at this point. I should probably put an arrow or something because I'm like doing bad math. 8 times 64. Okay, hold up. I got it. 128, 256, 512. And it's only this part that's equal to 0 that I really care about. Mush these two together to make a 16? 16? 16? Yeah, negative 16. Move it over, divide. I know I can do this. That's 4, and I have to go backwards. Oh, darn. 256, 128, 64, 32. Is it 32? Yeah? Okay. Now that was x squared. So my x is good enough in this class. Man, I like that. And I want to verify before we keep going, because what we just did was a whole lot. Yeah, there we go. Right, because 4 times 4 is 16 times 2 is 32. Yep, cool. All right, we're on the right track at least. So big picture, zoom out. We found the curvature. It was ugly. We simplified it for once in our lives. Once in our Cal 3 lives. Because we knew we had to say that curvature derivative equals 0. Derivative, however you like. I like quotient rule this time. Yeah.
Stuff that you just did before, that's
This guy.
yeah. Just making sure that nothing else changed with that.
Nope. Nope. And it's still there. I just didn't care.
Yeah, it's not important.
Correct.
That equals 0. 0, yeah.
Right. Correct. Very good on that. Note that this is positive, and so we always have a positive number plus 64. You'll never get negatives, so you can't even reach 0 even.
Okay.
Yep. Good analysis, though. Correct. Correct. And that's important when you're moving on to other things like DiffyQ has a lot of that stuff where you'll have an answer is like more like an area and then there'll be like a line slice through it because you can't use it. Yeah. Exactly. Cool. Now, how do we get this last part? Like, what are they asking for right here? The what now? I mean, actually, yeah, you're right. I was going to say the y value, but you're right. It's the curvature value. This is k equals, isn't it? So that would be back to my original. Oh, yeah, definitely. Yep, I'm going to plug that dude in up here. So square root 32. So notice that this is squared. So you have 32 and 64 make 96. I think 92 or 96, 96. And then you're going to square root and cube it, and I don't really know. And then there's something up here, and you get some math, and there's the answer. So great. Good job. If we got X, we're totally good with the other one, okay? So yeah, plug it back in essentially. Plug it back in. Cool, cool. So if you remember, we started on the last problem already halfway because we had done the curvature, right? And then we did this one problem. So we've basically done 1.5 problems in 45 minutes. So this whole like pick it up where we leave off is going to be important going forward, right? Yeah, because this is it's just one of those kind of classes. Yeah, I'm figuring that out too myself. I need to like make more pages.
Yeah, just like one problem per page.
Yeah, I think I might.
I think that will set up the proper expectations.
Early, right? You're gonna be using this a lot, yeah.
I'll just write that on the corner so I can look at book, and then I'll have a page dedicated to the rest.
That's
That's like, okay, move over, right out of room. Okay, I gotta switch to notebook. I still like the idea of just setting up the proper expectations. One problem per page.
yeah, I like that. And it keeps going through my mind how I didn't have one of those problems like this on there at all with the angles and finding the forces. Yeah, it does. Why did I not have it in the workbook? I don't know. Yeah, exactly. So yeah, that's in my brain that I definitely need to put that in here. That he forgets it?
No.
Oh.
No. That kind of problem. That exact problem.
Yes. Right. Okay. So I know that it seemed like this is actually the last section of 13, but 13 is not due this coming Monday, is it? Or is it? It's not? Cool. So similar to what we had last time, we're not gonna finish this today, obviously, but we'll probably get it done Monday. I'm not too worried. And then Tuesday, we can probably do the lab, or Monday, Tuesday. Well, you're not gonna be here regardless. I'm sorry. So yeah, Monday or Tuesday, we do the lab whenever we have time, and then we have like go back through the homework days. You know what I mean? I don't know what you want to call them. And then we got a review for the exam at some point too. So that's going to be fun. This section has been cut down a lot. So the unofficial, now it's official. Now I'm recording. I cut like half the homework off, and they were only the more difficult ones. So we only have easy problems left on the homework. And the main thing is this ATAN stuff. So that's tangent and normal components of acceleration. And then we have this B, which this is the formula for B. It's very simple. You have your T, you have your N, and your cross product. Now you're thinking, hey, Chad, that looks like a lot of work because I have to go find T and then N and then I cross product. You're like just compounding the problems. But on the homework, they're already giving you T and N. You just find the cross product. Okay? Yay! On the homework. And then in the exam and quiz, that's the only way. Actually, this is not on this. I don't think this is on anything else, just the homework, actually. I saw it. I did not see it on the quiz. Definitely not the exam. It won't take as long because they give us both of these. We're just doing a cross product. Yeah, but it's a cool concept because we already have N and T. So what would B look like? It looks like this. That's all it is. And this is how you're calculating tension, torsion, and all that stuff. And that's why it's used in the formula and blah, blah, blah. And so unofficially, again, we're not going to have this at all in the class. I just removed it from the homework entirely. So I have to say, though, the very first questions, this is directly from the homework. This is a great question right here. And this one, too. Okay? This is all legit. Like exam material even. Okay, guys? Like right here. This is awesome. This right here is not on there. And the reason why is because I would love to have that. See how they give us T and N? But I'm not going to do that. So I just deleted the whole problem. Okay? Same thing with this one. Anything with this, I just deleted the whole thing. Okay? It's gone. It's just gone. So that's not on there. And it's whatever. But what I'm going to use on this is that you see how we have the T and the N. I'm going to find this to supplement. Like there's the two questions on the homework that still have just B. And so we're going to do that. but we're not going to find the torsion because I don't care. And it wasn't in the WebAssign class. None of that was in the WebAssign class, so whatever. But I want to go way, 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 way back to here. So I know that this is the last section, and they had these formulas, and we never really used them. But these formulas are better than the formulas in that other section, okay? So I would rather use these, and I was doing this before class to kind of like make sure I was doing it right, because this has always been a sticky point for me. Like, Chad always gets this wrong, okay? And I went and did it, and I got it wrong the first time. So I was like, oh no. So I went back to these formulas. These are the legit formulas. Again, do you want to use something with S in it? Probably not. I mean, it's not as bad because there's a T down there. Did you want to blah, blah, blah? I don't know. But I would prefer these two right here are awesome. In particular, these guys. And that's what I'm going to use with you here, okay? So note the similarity. We have a dot versus a cross. And they're both divided by magnitude of V. Now, why is it that the cross product also has magnitude? What kind of makes that similar now all of a sudden? It makes it positive, but it also makes it a scalar. Dot product is a scalar. Cross product is not, but now with the magnitude it is. Exactly. So we're making it a scalar now for all this. All this is scalar, which is nice. So we're basically looking for like 4, maybe 6 questions total, and very, very straightforward. So here we go. My formulas again for the A sub t was V dot A over magnitude of V. And my A sub n is magnitude of V cross A over magnitude of V. Am I correct about that? Like, verify. Thank you. Thank you. Okay. Notice that these have T's and stuff. But it also has T equals 1. Now, this is one of those these things that you probably learned along the way, and I don't know if anyone told you, but you probably already figured it out. You don't plug in 1 right now. You plug in 1 later, right? If you plugged it in right now, you would have numbers, but it wouldn't be a good result in the end for some reason. Blah, blah, blah. And I don't know if anybody tells you that. I don't know. I don't tell my algebra folks that, so they have to figure it out too. Let's go and do this stuff. So here we go. V, R prime, either way. What do I have? 6t, very good. Yeah, exactly. A, R double prime. Perfect, perfect. And now we're gonna have to like dot and cross them and stuff. So I'm gonna do R prime dot R double prime. Let's start with that. I know you already know the answer. You can just see it. Oh, 0, 0, 30, 60. Sweet. Exactly. You're multiplying these two together, multiplying those two together, multiplying those two together. So 2 negatives make a positive. Perfect. Perfect. And that's a scalar. Even though that has a variable in there, that's still a scalar. All right, now for the cross product. Not as easy, but there's a whole lot of zeros, so that kind of makes it easy, I think. Let me attempt, I guess. I mean, y'all can do whatever you like. So 0, always a 0. 2 times 0 is a 0, and I cross k is a negative j. But that would be a positive then, because 2 negatives make a positive. Anything times 0 is 0. 0 always. Negative 18i. And then 0, 0, always a 0. So then negative 18, positive 6, 0. I think. question. It's 12. Thank you. Yes, thank you. Good one. Good call. I get so wrapped up in everything. Thank you. Good. Very good. Good eyes. Good eyes. Excellent. Cool. Yes, much better. Much better. Magnitude. I always forget. I need to find the magnitude of that guy, right? Square root of the squares. Y'all don't know that? I'm just joking. For reals? You already know it? Oh, okay. Can I verify? I'm gonna verify. I do agree with you. I'm just so yeah. Square root of the 468. Does that actually make a nice, pretty thing? Oh, womp womp. Well, we keep it that way then, because it's calculus 3. Mm-hmm. And you know what's interesting is that both of these are scalars, right? That's nice. But a scalar can still have a t. It's just that this one ended up not having one. If you notice, the only thing that had t was way over here. But when you multiply it by these guys, you got 0, 0, and then it was an auto 0 because k times k is 0. So this could have had a t in it. In other problems, we might have a t there. Okay, it just so happened to not have a t this time, strangely, but it works. I think the only thing left is that magnitude of v, which they both hold in common. So I'm looking for magnitude of r prime, square root of the squares. So 4, 9, and 36. Yep, t squared. Yes, magnitude. Yeah. Thank you. Thank you. Yes. Yes. I mean, this is the Wild West, but we don't shoot anyone we just see, okay? So. Very good. Okay. Let me try to. Okay, so I like circling because we're going to use those as components. Again, that one had a t, so be it. So my a sub t is going to be the 36t divided by that stuff. And if there was a way to simplify, I would try, but I don't see it. 68. And the same with this guy here. They both have a square root, which means I could technically mush them together, but I just don't think it's going to help. So what I'm going to do is flash the answer real fast. Flash the answer. Well, once I have it, sorry. Not the same. I had said, don't plug in the T, don't plug in the T. How many times have I messed up on this one problem, right? And thank y'all for working with me on this. Yeah, go ahead. Thank you. Yep, there it is. It's 36t. Yes, it will turn into a 1 in a minute, but there I go again.
Well, it helps because I'm like, I see that 36, but I'm not quite sure if that's the same.
It was. You're right. Thank you for noting that. You're right. Thank you. Was that 40? No. Yeah. And then there's a set. Ah. You got it. Yeah. T equals 1 at the top. Yep, T equals 1. Yep. Let me expand here. Maybe we get some more room. Cool. That was not too bad. It's all about proper formulas. That's the thing. I tried one of the other formulas they had given us, and it just totally flopped. Like I was totally lost. And I'm just using the more standardized formulas. It's fine, you know. So this acceleration in terms of this and that, I mean, it's like the centripetal force. How much is going in this tangent direction versus normal direction? And so, oh, you know what? I want to do a demo. Ooh, it's a deadly demo. Hold on. Y'all got a minute, right?
You got 3 minutes left on the clock.
Oh yeah, I'm gonna find it.
You got the Jeopardy music?
Christmas lights.
Like Chad, you have gone insane.
All right. The end, the plug, right? The plug. So I'm concerned about the plug. Yeah. Where's the acceleration going? Around, right? Toward my hand, right? Or it may be away from my hand. Normal vector only. Or if I, sorry, I'm gonna actually throw it. But like, notice that it's still going, right? Towards my hand. But it's also now going that way. And so we've basically gone from my tangent would have been a 0 technically, because it's all normal. But then I release and it transitions from this to that slowly, right, over time. So eventually my normal would be 0, and then this would be back to normal. Back to full. Can't say normal. So interesting, right? How that works. And so that's kind of like, again, when you're going around, but then you go whoosh. So there's that momentary, for a while, it's kind of having both as it transitions, and then it goes straight. So, and that, but it's important for those kind of aspects. Good to go?
Yep.
Thank you, guys. Y'all have a great day. Thanks for watching and hanging out.